Alright, let's continue building our bytecode compiler. And we are in this part of the book right now, equality and comparison operators. So last time we introduced nil, true and false, like new values to the programming language. And now let's introduce some operators on this these new types. So we're going to introduce equal, greater, and less. So we only added three operations here, but there's three more missing, like not equal. We have equal, but we don't have not equal, and so on. But we're going to write not equal as two operations, not or equal and then not. So let's go to the parser now, which is in here in main in the compiler for reasons. And then we need to add handling of these symbols. So equal is gonna need to be handled as a binary, and the precedence is of equality. I am not entirely sure that we have that. Let's take a look. We do have that. Let's get rid of that one. Then there is greater. It's also a binary operator, and the precedence is comparison. Let me disable Copilot because it's a bit annoying. Then greater equal. Same thing. And less. Same thing. Honestly, we should probably do like this. Less equal binary, and then none. Change that to comparison. Go here. Stop recording the macro, then apply the macro. Not applied here, but we have less equal. Actually, that was also a bit overkill to make a macro for that. A bit macro. Anyway, so now we need to handle these new things inside of the binary function, which is this guy. So now if we see, let's handle equal first. So we're gonna emit a byte that we have to cast, and it's gonna be the equal operator. We're gonna break. Don't think we need to break actually, but we'll do it anyway. So maybe this one is a bit more interesting. If we see not equal, we're actually gonna emit 2 bytes. You know, at this point I really don't want to cast here manually, so I'm gonna, let's see, do we even have this function? I'm not sure we do. We do have it. I wonder, does Odin have overloading? Can we do this? If we can even type. And then in here, can we say cast to U8? Let's see if that works. And let's do the rest. It's greater. It's a single byte. If it's greater equal, then it's 2 bytes again. So not less. And less is pretty easy. It is just the less operation. And less equal is again a couple of bytes. It's greater and then not. Okay, with that, let's try to run this. Let's try to build it first. And it didn't eat that. So I think we don't have overloading. Let's call it ops, and then we're just gonna use it here. Later we can refactor to use this everywhere. But for now, let's try this. Try to build it again. And here we have a bunch of errors. It's not, is it not called? Is it not called prick? It is not, it's just called no prefix. And now in line 190, what? Oh, it's another file, sorry. Here, okay. So we're gonna need these new operations we added. Let me open them up over here. Equal, greater, less. So case of those. Okay, so equal, what do? We need to get two values from the stack, I guess. So kind of like this. And I suppose we can just push value 1 equals value 2. And that's that. Here again, we need to get two values and then do something with them. But these two are a little bit more tricky because we need to check on the type as well. So let's see. Let's do something like this. I'm not sure what to call these functions right now, but this will be fine. And you know what, we have this pattern down here, so let's do the same. Let's say run greater, and we'll say okay is this, and if not okay, then we'll return an error. And the same thing down here, but we will say run less. Okay. Let's see how these guys are built. They're built something like this. Then we switch on the value. So which value types do we have? We just have a number, a boolean, and nothing. And I think greater should only work for numbers. So we'll do something like this, and the result is B greater than A? I think that's how you want to do it. So before we do this, then the stack looks like there's some stuff, and then there's A and B. And then you push the greater operation. So that should say is B greater than A. I think that's the most natural thing. All right, let's get this guy and run less. And actually this guy should probably be the same. Just to keep it consistent. Same thing. And run equal. Now, actually, equal should also work with other types. So let's say if the type is Boolean, let's maintain the default here, and let's just do this thing. Okay. Anyway, so it's a Boolean. What are we gonna do? Let's get the value of B as a Boolean. That is how we do it, right? So let me check. It is just called Boolean. Then, if that's also Boolean, then we can compare it. Sorry, let's call that one A. And then we push that stuff onto here, and we return true to say that it succeeded. Otherwise, it failed. Come on. And the final case we need to handle is nil. So here we don't need the value because it's just a unit type. And here we can say that you can maybe we should allow comparing many different types. I guess why not? So less than and greater, those need to fail if the types don't match, but this equal, it can just do this. And same here, we can say that the only thing a Boolean can be equal to is another Boolean. So false if the other thing is not a Boolean. And the same thing here, so we can just do that, return true, and there we go. Let's try to compile again, see how much we're missing. There is no opcode.not because everything is called up not. Same with the less for unknown reasons. And still there's an up not, there's just a, here it is. Okay, so now it builds. Let's try to run it. And let's say 2 is less than 3. That's false. 2 is greater than 3. That Okay, so we have some kind of sign. We clearly have a problem. So let's go back into the VM and let's see here. So run equals probably fine. This one had a problem. So it's not. It should be like this, which is a little bit weird to me, but I guess I'll try to make sense of it. So let's think about it. So when we do this, first 2 is pushed, then 3. So we are. So the last thing is on the top of the stack. So if we go and look here, then it would be 2 is seen first, so that's pushed to the stack. Then 3 is seen, so that's pushed to the stack, and then we do like that. And then indeed, this would be 3, this would be 2. So we have to say A less than B. Okay, I think it makes sense again. And let's take a look at the book again. Okay, I just realized we made a small silly thing here. We can just do this. I think that should work. Then return true, because you can compare anything. It doesn't like that. That's interesting. So now can I say, yeah, now we can say all of this stuff. Great. So yeah, of course, run equal is simple because we can compare any value, and we just do like this. Actually, we should make one more test because I've only been comparing numbers right now. So let's check this one. Okay, that's not the case. That's the case. Is true equal to true? Is true equal to false? Is true equal to nil? True equal to nil? False equal to nil? All right. So the last thing we're going to do is disassemble these instructions. So we need to go back to the disassembler, which I think is here in chunk. And actually, it's already working fine. I just realized. So maybe we don't have anything else to do. And let's call it a day, I guess. So I will see you in the next one.